Okay, so this week we're going to be starting a new topic. This is the database phase of our course. We're going to be talking about databases, database design. You're going to be eventually designing your own database. And then, of course, we're going to be talking about basic CRUD, create, retrieve, and update, and destroy, the way that you can interact with a database. In other words, SQL, which stands for the Structured Query Language. So it's yet another programming language, but it's for programming databases, okay? And the reason that we need to do this is because programs are short-lived, right? Data is not. The data needs to persist or be saved across multiple different iterations of your program. One program can be launched, and then it analyzes the data, produces a report, and the program is done. But the data still needs to be there. Up till now, you've been processing data in multiple formats, for example, CSV, or structured files like JSON or XML, and those are not sufficient because those have a lot of problems. Here's an example, right? So consider the following we call these things flat files. You can view this as a CSV file where each one of these columns is separated by a comma. What are some problems with this data immediately that you see? Anyone? It's unsorted, so if I wanted to produce a report, say, for everybody in 156, I would have to process the entire file to find everybody in it. Yeah, another one.
There's a bunch of different ways of representing this data. This is at the very top. There's just two things missing at the bottom.
Yeah, multiple different ways of representing the same data or missing data. Here we're presumably using empty strings. Down here we're using the keyword none. And over here it's null, right? Not only missing data, but the data that's actually there, right? We've got Tom Waits there on line 3. But then we've also got Waits, Tom on the first line. Right? So different ways of representing the data, and it leads to what are called data anomalies. We've also got a lot of repetition of data, right? We've got multiple people in 156. And the data for 156, the course number and the course name, that appears multiple times, right? So we've got, and the NUIDs appear multiple times over here as well, right? So we've got a lot of problems with this data and that we need to solve, right? It's a terrible format to search or consolidate data, as you pointed out originally, right? It's not sorted, right? Flat files can only be processed by one program at a time. Have you ever opened up a Word file and then go and try to delete the file on your hard drive? Try it sometime. It won't work. It'll prevent you from doing it because there's what's called a file lock. Once a program is running that is reading that file, or they've got a lock on that file, right, then nobody else can deal with that file. Imagine if Google only allowed one person to use it in the world at once, right? Computing doesn't work like that, right? We want to be able to have multiple programs or multiple users access the same data. Data is repeated unnecessarily. There's also consistency issues that lead to data anomalies, right? What if I changed 156 from intro to CS2 to I spelled it out, computer science 2, right? I would have to go through and change that for every single occurrence of the course name over here. What if I messed up and I only changed it for 1 or 2, right? Now we've got data anomalies, like you were investigating in your first assignment, right? Missing data. There's also integrity issues. There are different ways of representing missing or non-existing data, as you pointed out. But also, you know, there are no way in enforcing types. I don't have any in this particular data, but what if I had a GPA, right? And which is on a scale of 0 to 4.0, and it is a double, right? There's nothing to prevent me from putting in hello, H-E-L-L-O, into that field because it's just a text file at the end of the day, right? Even if you're dealing with XML or JSON, right? That's just a text file at the end of the day. Organization, again, it's not sorted, as you pointed out. And something that nobody pointed out yet, but we really need to think about it, is security. Right? There is no security at all with a text file. Right? I mean, there is in such that I will only allow certain programs to read this text file, but that means that they can read the entire file. Right? What if we wanted a user to access any data that belonged to them, for example, my 156 data, but I'm not teaching 235. Why should I have access to that? Well, I've got access to it because it's all in one big giant file. Right? There's no security, there's no granular security there. And again, there are formatting issues here. What if I screwed up? And in fact, I did screw up here. There's a comma right there. That would really screw it up, right? Because now there are a different number of fields, right? And again, there are no type. There's no type safety here at all. There's no integer. There's no concept of an integer, string, or double. There's only strings. And so, what's the solution to all this? Well, the solution is go back to 1970, and you'll meet Edgar Codd, who invented the relational database management system. And we'll come back to Ed here later on because there's a nice mnemonic device for a well-designed database that's third normal form. That everything has to be dependent on the key, the whole key, and nothing but the key, so help me Codd. And we'll come back to that later on, right? The key aspects, though, is that data are not stored in one big giant flat file anymore. They're separated out into other tables. Let me show you a different picture of the exact same data there, but in a different format, right? This is a table up here, right? In fact, I've got 4 tables here. What is this table for? It's to store student stuff. This table is for course stuff. What's this table for? Looks like email stuff to me. And then this is what's called a join table that joins those 2 tables together logically, right? This looks a lot like object-oriented programming, right? Put stuff where it belongs. Student stuff is it's a student thing. Where does it belong? In the student class. Now it's a database. It's a student thing. Where does it belong? In the student table. Okay. So this, but of course, 1970 that predates object-oriented programming by a decade or more, right? Depends on who you ask on what object-oriented programming is, but. And then tables have columns, which are pieces of data, and rows, which are records. Again, if you only focus on the student table up here, the columns are pretty clear. There's a student ID, first name, last name, and an NUID. And then each one of the rows, 1, 2, and 5, those represent actual records in the table. Okay? Each column, and it's not in the diagram, but each column has a type and a name. I mean, the name is there, but not the type, right? Each row corresponds to a single record, right? Records in a table are uniquely identified by what are called primary keys. Right? And if you look from the naming convention over here, you can probably suss out what the primary keys are. Student ID, course ID, enrollment ID, email ID, right? Because I followed a good design here, right? I'm putting everything with an ID after it, right? And so those are my primary keys. And they're all unique. Once Tom Waits here is assigned a value of 1, nobody else can have that value. The database enforces that idea. If you ever try to insert a duplicate record with that value of 1, it'll reject it, right? Because it's a primary key. Primary keys are unique. Now, how do I relate data from one table to another table? Those are also called keys, but they're called foreign keys, or FKs for short. All right, let's zoom in a little bit. All right, there we go. That's a little bit better. All right. And you can kind of see what it is here. Let's look at the email table here. I've got a student ID over here in the student table, and I've also got a repeated student ID over here in the email table. That is the foreign key that refers back to the other table here. For example, read@gmail.com. That corresponds to student 2. Who's student 2 over here? Lou Reed. I can't highlight him, just him. But I'll just go Reed there. Right? Why? Because we've got a student ID of 2 right here. Okay. Student ID of 5, that corresponds to John's student, and so that's his email. Right? You'll see here, however, that there are duplicate records, 1 and 1, corresponding to Tom Waits. Why? Because Tom Waits has 2 emails. This forms what's called a one-to-many relationship, and that's depicted here in this diagram through this edge right here. It's a 1 relation, and then we've spread this out. It's a many relationship over here. Okay, so that's just one of the types of relationships, right? But foreign keys define those relationships. Right? Let's go here. Right? There's a one-to-many relationship that we just saw. Right? One record in table A may be related to multiple records in table B, or none at all. Right? We could have a student with no emails at all, no email record at all. Right? So it's a one-to-many relation. When we say many, though, we also mean the possibility of 0 or 1 or 2 or 3 or 4, all off to infinity there. Of course, it's a finite database, so we're not going to have infinity. Right? Now, you can also look at it from the other perspective, right? From the student table to the email table, that's a one-to-many relationship because I'm starting at the student table and traversing over to the email table. If I start at the email table and go over to the student table, then that's a many-to-one relationship. And it's just a perspective, right? It's just changing which table you're looking from and which table you're looking to, right? So one-to-many, many-to-one, that's all the same thing, right? Now you can also have a many-to-many relationship, right? Where you have two relationships. You have a one-to-many relationship and then a many-to-one relationship. From table A to table B. The usual way that we do this is through what's called a join table. And you can see that in action over here in this diagram. That one student can be enrolled in multiple courses through this email table right here. One course can have many students. I meant to highlight it up here. One course can, of course, have many students. Right? And so from the student table to the course table, we now have, through this intermediate table, we've got a many-to-many relationship. One student in many courses, one course has many students. Right? Now you might be asking yourself, there is one more kind of relationship, and yes, it is valid, right? It's called a one-to-one relationship, where one record in table A is related to only one, at most one, record in table B. It's not generally as useful. You should prefer one table, because if there's one record over here and one record over here, and they're related intimately, like there's only that one relationship, why are they in different tables? Right? Put them in the same table. Now, unless, of course, there's a very good reason to do so. And remember, very good reason, all capital V, capital G, capital R, there has to be a really good justification there. Okay? We're going to start with a pre-existing database for all of our demonstrations. I'm going to demonstrate CRUD, right? And you'll see this all over the place. It's an acronym that stands for Create, Retrieve, Update, and Destroy. These are the four basic operations that you can do with your tables. You can create records by putting the new records into the table. You can retrieve records, pull records out of the database for reporting. You can update, you can change the pre-existing records, and you can destroy them. You can delete records. In fact, these four basic things are with any data structure. If we're talking about maps or lists or sets with Java, of course you can put stuff in, you can take stuff out, you can update stuff, you can remove stuff, right? So these four basic operations are going to pull up everywhere that you see data or data representations, right? So it's in any data collection. All right, so we're going to learn a new language here now, right? We can interact with an RDBMS, right? A relational database management system, through CRUD, right? Now, create, the keyword here is insert, right? Retrieve, the keyword is select. Update is the only one that makes sense because it's the same keyword there, update. Destroy at least starts with a D there, and so it's delete, right? So insert, select, update, and delete. But ISUD, ISUD it doesn't roll off the tongue like CRUD does, so we use CRUD instead. You can insert new records in the table, you can pull out new records in the table, you can modify records. However, removing, deleting, there is no undo, right? You're used to nice desktop computers with nice graphical user interfaces that save the user from doing stupid things like, oh, I didn't mean to delete that, right? I need to retrieve that. I can always go to the recycling bin and restore it, or I can always, pull it from a backup copy or something like that. Nope, no undeletes. Right? Once it's deleted, it's done, right? Now, in the database world, if you are a database or what is it? Not a DBA. What are they called? A DBA, a database administrator. Yeah, if you're a DBA, then of course you'll have all these tools at your disposal that you'll make nightly backups and quarterly backups, et cetera. Then you can restore from that backup. But by itself, there's absolutely no undo. So we have to be careful here. Right? Now, you will be getting started. I sent an email to the admins to send you your passwords, but I will show you how to get started with this. You won't need it until next week, but you should get the passwords midweek sometime. We recommend that you use another IDE called MySQL Workbench. All right, and there we go. It's a free download. It is compatible for the most part with the database that you'll be using. You won't be using MySQL. You'll be using something called MariaDB. It's a clone. It's a free and open source software clone of it. MySQL itself is owned by Oracle. MySQL is free, but it's not free as in freedom. It's not open source. And don't bother with setting up your own server. We're going to give you a server to work with, along with a password. But otherwise, you can download MySQL Workbench here. It'll look something like this. Download it for whatever system you've got. I've got a Mac here, so DMG, whatever, right? Once you have downloaded and installed that, it's going to look something like this. Let me go ahead and get rid of that. There we go. All right. It's going to look something like this. Now, I've got pre-existing links here. However, when you create a brand new link, you're going to have to hit this plus button here. Name your connection, whatever you want to. I don't know. It's on the Neuros server, so you could call it Neuros or computer science or something like that. Your host name is 127.0.0.1. That's your computer, right? That's always going to be the local host. You don't have I don't know what the IP address is. It doesn't matter. Instead, you're going to go neuros.unl.edu. Do not mess with the port. That is the standard port for MySQL. Now, be careful because as long as you're on campus or as long as you're on a VPN, 3306 is open and you're good to go. But if you're off campus, we were trying to get them to change this as of maybe a month ago. I've not checked in with them, but they were blocking it. ITS was blocking it from off campus to this. So you might have problems. If you're off campus, just use UNL's VPN. I forget what the VPN is called. That's a virtual private network. If you've never done that before, it makes you look like you're coming from somewhere else, like you're on campus instead of off campus. You use it all the time to try to get past checks that, oh, you're in the United States, you can't watch that show here on this service. But if I'm in, I don't know, England, now I can watch it, right? That's what VPNs are used for, mostly, right? And you are not root, right? You are going to be you. I am me, so cberg3 would be me. Whatever your login is to Neuros, whatever your login is to, it's the same one as Canvas, basically. And then you'd say, okay, and create that connection. I've already created that connection, so let me go ahead and come over here and double-click it, and it'll open it up, right? Now, that means that the connection is probably okay. Note that, however, I already entered my password for this. When you go in for the first time, it's going to prompt you for your password. It is not your Canvas password. The password will be sent to you via email by the sysadmins, all right? If you need to change it, you can. I wouldn't recommend it. It's just auto-generated. Don't use that password for anything else because eventually we're going to see that password in your Java code, okay? If you lose your password, right, then you're going to have to email manager@csc.unl.edu to get it back, all right? So in review here, let's go back to our notes over here before we start, right? You will have access to a database server on neuros.unl.edu, right? Your password will be sent via email, right? And of course, if you're working with a partner, their partner will also see that password, right? You'll each have your own password, but that's why we tell you don't use it for anything else. Don't change it to any sensitive password, all right? Because other people will see it. If you lose it, you're going to have to email manager@csc.unl.edu, and they're going to have to manually change it. Give them 24 hours, maybe 48 hours. Definitely over the weekend, they're not going to be answering. So make sure that you are keeping track of that password. Don't just delete it, okay? But otherwise, at some point, once you get that password, I would recommend installing MySQL Workbench as soon as possible, at least getting it up and running and saying something like, if I just, let me show you something first. Show tables. That will show me what the tables are that are already in this database. I thought I could increase the size here. Nope, I can. There we go. I'll just zoom in. There we go. Show table. There we go. All right. Now this is probably not going to work because I've not said which database I want to use yet. So at the top here, I'm going to say use cberg3 because that's my actual login right there. By the way, what are those special marks right there? Those are called backticks. You'll find it on your keyboard all the way to the top left. It is right under the tilde, right? And you just need to, I think it's, yeah, you type it without holding down the shift key, right? So I'm going to use my database. oops, semicolon at the end, right? See down here at the bottom, anytime I execute a command, it's either successful, green check mark, or it's not successful, red X, right? Now I can show tables. What are the tables that are currently in this database? There are 4 tables in there called availability, game, platform, and publisher. We'll talk about that here in a second, right? But initially, you're not going to have any tables at all, right? Initially, it's going to look something. It's just not. There won't be any results here at all, right? And so you need to either create a table or install a table. We walk you through that process in Lab 7 next week when you have to install an albums database. But otherwise, at the very top, you have to use CBER. Now, let me undo that. To run the entire script, you can go ahead and click this button up here, right? And that will execute everything. That'll see both of those commands are executed. Use my database and then show the tables. Right? You can always close this, by the way. If you just want to run one of them, then it's this other one up here, the lightning with the eye there, right? And that will run one command. Whatever command is currently under your cursor, right? Now the quick keys for doing that on a Mac are going to be Shift, Command, Enter for everything, and then, come on, close that, and then just Command, Enter for whatever one single command that you want to execute. Or you can always just click up here. For Windows users, I have no idea. Right? Probably Control Enter and Control Shift Enter would be my guess, but you're going to have to play around with it. Right? All right, what about those tables? Here's what it looks like. So we'll go ahead and get rid of this enrollment stuff over here. All right, get rid of that, get rid of that. Okay. And here is a video game database. Right? So I've got a game table, a platform table, a publisher table, and an availability table here. Right? My game table is responsible for game stuff. It's got 3 fields in it. It's got 3 columns in it. One of them is the game ID. What do you think that is? Remember, how are records uniquely identified again? Through primary keys, PKs, right? How do you know that that's a key? Maybe kind of a little difficult to see that, but what is that little icon there? It's a key, or it's supposed to be a key, right? What type is it? It's an int, right? Just like our Java code or our Python code. It's an integer, it's a whole number, right? In fact, it's a 32-bit signed or unsigned, probably unsigned integer there, right? Name, what does that little symbol mean? We'll come back to that. Varchar, that stands for variable character, up to 255. In other words, in MySQL, that is MySQL's representation of a string. But it has a limit, only 255 characters here. I could go back and I could redesign this database to have 250 characters, or I could design it to have 1,000 characters. Right? 255 is just an old school placeholder, right? It's big enough, but it's not too big. It's just Goldilocks, right? It's just right. Then I've got a publisher ID here, right? What do you think that corresponds to? The publisher ID over here in the publisher table, right? So these two tables have a relationship. The relationship is that one publisher could have published multiple games, right? Now, in the real world, you could probably say that one game could have multiple publishers, right? If multiple companies were involved with it. That's not what I'm modeling here. That would be a different schema. That would be a different database. I'm keeping it simple here. The publisher table also has a name, which is a varchar 255, a string, right? And so that's how I can bring those two tables together. This game was published by this publisher, right? And that's their publisher's name that did it. A platform is kind of like a publisher, but it's got a primary key and it's got a name as well. That's the platform that it's available on. PC, Xbox, Xbox X1 or whatever they're on right now, PS5, right, et cetera, Switch, right? And then I bring those two things together because one game could be published on multiple platforms, right? The AAA games could be published on all the consoles and PC, right? And one platform, of course, hopefully has multiple games, right? If you had a platform with only one game on it, would you buy that platform? Not unless you were really into that game, right? Right. So there's our setup. Right. Now we're going to review basic CRUD. Basic CRUD. CRUD. There we go. All right. So inserting records into the database. Right? In other words, we're going to be create. Right? I should say like this, create. Right? In other words, we're going to insert records. Okay. Let me come over here and let me insert a new game. Insert into game. Right? So insert into, those are the keywords. They're being highlighted in blue here. That's why you use this, use an IDE that's going to have syntax highlighting just like Eclipse does. Right? Now, you could go old school here. The old school way of doing this is insert into game. And then we'll get to the rest of it here in a second. Right? In other words, if you were going back to 1970 and being chummy with Edgar Cod, right, then you would not have color monitors. If you didn't have color monitors, you didn't have syntax highlighting. And therefore, to offset all of the keywords, you made them all caps. SQL is a case insensitive, though, on all the keywords. Right? That's because you didn't have color back then. We have color now. Right? Save your pinky. The pinky's always holding down the shift key, right? If you're doing this, it's all caps, or you're always putting on the caps lock, taking it off, putting it on, whatever. So just save your pinky and just go all lowercase. Right? That's the modern way of doing it. So I want to insert into game, right? Let's see, a game. I need values though here, right? Now the game requires a game ID, but remember that this is a primary key. I let the database handle that, right? It's not gonna. I don't want to have to worry about that. I want to insert a new game with and so I have to give it the publish name and the publisher ID. So name, comma, publisher ID. Right. It was, oops, it's not underscore, it is publisher ID, camel casing, right? We're also using a modern convention there, right? By the way, it's a game table, it's not the games table. It holds game records, right, plural, but we keep this singular. We saw that with several folks doing that with their Java classes. No, you use lower camel casing singular, okay? Values, right? And then I need to provide some values here. So give me the name of a game, a recent game. What's the big game right now? What?
I was just going to say Cyberpunk 2077. That's not what you said.
We'll go with it. Cyber what?
Cyberpunk
Punk 2077. Okay, great. And who's the publisher?
CD Projekt Red.
Okay.
It's spelled really stupid.
Don't worry, I'll just say CD Red or something like that, right? That's our new game, right? This is an old database, right? Do you think that publisher is going to be in this database? If they are, who are they? So I'm going to go ahead and jump here to the retrieve, the R of CRUD, and I'm going to select everything from the publisher table, right? There are all the publishers. Many of them do not exist anymore. LucasArts was bought out and I think it shut down, right? Square Enix was bought out and shut down. Sega still exists, but do they do anything? I don't know. Nintendo definitely exists. Rockstar exists. Blizzard, Capcom, Atari. Atari doesn't exist anymore. Eidos, I don't think exists either. Valve, they exist. Namco and Delphine Software, right? Do you see what it was called? Red One or CD Projekt Red, right? So I don't see them here. How can I possibly insert a game record if I don't have that publisher record? So let's come back over here and understand the order of operations, right? This is what's called a parent table, and this is a child table. One parent can have many children, right? But can a child exist without a parent? We call those things orphans. And we don't want the orphaned records in our database, right? In fact, the way that we've designed this, we can't have orphaned records. The parent has to exist before the child record here. So in other words, I have to create the publisher record before I can insert the game record. So let me come back over here and do that. All right, so publishers must be inserted before a game record. Right? What do you think that is right there with the hash there? Python folks, what is it? It's a comment, right? So it uses the same syntax as Python. Python actually probably took it from that or some other language. Alternatively, you can go hyphen hyphen. This is a comment too. Right? And you can do, I think that you can also do // Nope, you can't do // but I think that you can do multi-line comment. There we go. Yay, you can do all of those things. Keep it simple. All right, there we go, just go with that one. All right. So insert into publisher. Now in this case, I only need a name. Why? Because that publisher ID is a primary key that will be auto-generated for me. That's the way that I design this database. That's the way that you're going to design your database. You could go off on your own, right, on your own tangent and design databases without proper primary keys, without proper foreign keys. Yes, you can do that, and believe me, it is a huge headache. Right? We have relational database management systems for a reason. Key management is a very, very difficult problem that is solved by a database. Let it do its job. Right? So I'm going to let it do its job, and I'm just simply going to insert the name, values. Right? Now note here, there's only going to be one value. You still use the values keyword. I believe that you can use value, right? But be consistent and just go with values. I'm going to show you how to insert multiple records later on. And the name was what you said? One CD?
CD project red, and then project is with,
Red, like that?
yeah, and then red's all caps.
Okay. All right, there we go. I'm going to execute that one. Green. Green means good. Green means it was working. If you ever need to, by the way, you can go ahead and clear out this, these commands down here if you need to. Just right-click and select clear. Let me come back up here and see if it actually did work, and it did because it was green. Right? But what do we see down here? CD Project Red. What is their publisher ID? Their primary key value is 14. Now that I've got that, I can go ahead and put it in here as 14. Right? There. Now you can insert a game record, right? And let me zoom out so I can see a little bit. There, that's good enough, right? And let me give myself some more real estate too. There, okay. Now you can insert a game record, and let's go ahead and do that. Right? Enter, and that also is green, right? That's good to go. We can also check to see what games are in there. Select everything from game. And we now see Cyberpunk 2020 or 2077 is there, and it has a publisher ID of 14. And guess what? It created its own game ID of 21. It's in there already. Okay. What's another game that they made? Witcher something? The what?
The Witcher.
Okay, like that? All right, we'll go with that. Oops. Fat fingered it. Is there a publisher with ID 16 there? Nope. So I get a red X, right? That insert into game, the error, cannot add or update a child row. Remember that those are called orphans, right? That I tried to create a child here with no parent, right? No valid parent, I should say, okay? And so I got rejected there, right? Now, I forget what their ID is. It's right there, right above. But what you can do is, alternatively, what you can do is you can create, you can use subqueries to get values of keys. For example, what I'll do here is I don't know what this thing is. Right? So instead what I'll do is I'll put another query in there. Select the publisher ID from publisher where, and this is kind of getting into what we're going to do next, a retrieval, CRUD, create, retrieve, update, and destroy, where the name of the publisher is equal to, what did you say, CG Project Red? There we go. And there is only one publisher with that name in there, so it should work. If there were multiple publishers with that same exact name, first of all, I'd say that that's bad data. We should prevent that somehow, and we'll talk about how to prevent that later. But otherwise, it works here because it's only one. If there were multiple, if there are 2, 3, 4, then this would actually be a set instead of one single value. In which case, I would get a red X. Which one of them do you want set to? It's 14, 15, and 16, right? I can't set them to all three. You're going to have to redo your query here, okay? All right. There's inserts into. And by the way, it's the same everywhere. If you want to insert into publisher, if you want to insert into availability, et cetera, et cetera. If I wanted to make, I assume Cyberpunk 2077, is it on PS5? Okay. So if it's available on PS5, I would have to make that sure that PS5 is a platform. And then I could make this double child record. I've got two parents now, right? And I would have to have the game, and I would have to have the a platform in order to make them available on that platform, right? All right, that's inserting records. For now, I'm going to jump ahead here to updating records. Right? So we're going to update. Right? Suppose I meant to. Did I spell it right? Witcher?
Yeah.
Okay. Give me another publisher. I don't know any. Who does Roblox? Roblox. There we go. Roblox is the publisher of Roblox. Is that right? Oops. I didn't mean to save it, but okay. Roblox is the publisher of Roblox. All right. Is that how they spell it? Nope. Yeah. So we need to fix it. Right? Fix records that already exist. Right? I'll show you that that record exists, publisher, right? Roblox, right? But not with an X. And so what we need to do is we need to update that record. By the way, what publisher ID was it? 15. We need to fix that publisher ID. So what we can do is we can say update publisher set name equal to the correct name, Roblox, something like that. All right, now before I execute this, just read it in plain English. What do you think is going to happen? Update the publisher table. Set the name of who? Everybody. Red X. It's preventing me from doing that because I'm in what's called safety mode. If safety mode were off, and there are ways that you can shut off safety mode, I'm not going to show you. Right? If you want to, you can go ahead and go off and be a cowboy and do whatever you want, yeehaw, and shut off safety mode and start screwing around. Right? Safety mode prevents me from doing this without a where clause. Where publisher ID is equal to, what was it again? 17, 16, what is it? 15? All right, there we go. Yeah, because CD Project Red is 14, right? So it just goes increments, but of course, if you go and delete a record, then it'll just keep going, right? And it'll eventually come back and start reusing unused keys. Again, key management, that's handled by the database. All right, now it'll actually work because I'm winnowing it down to one element, right? I could have said instead where 15 is equal to 15. That's how you can get around safety mode. I shouldn't have said that, right? But that's another way that you can get around safety mode. Why? Is 15 equal to 15? Yeah. All right, and it's not equals equals. It's just a single equal sign. I have a where clause. Safety mode is not that smart, right? It says, okay, you have a where clause. You must know what you're doing. I'm going to go ahead and let you do that. I'm not going to do that though, right? All right. So, and you can update as many times as you want. Of course, it's just changing it over and over and over again. But let's go ahead and see what my publishers are now. Now Roblox is correctly spelled at the bottom there, right? Okay, great. I didn't mention, they only got one game, right? So I assume, I mean, you make billions of dollars off of one game. You don't change stuff, right? So what we're going to do is, it's not that interesting. I don't want it in my database, right? This is the D, right? Destroy, which is equal to delete, right? Delete from publisher, period. Now, once again, if I try to execute this, what's going to happen? It's going to delete everything, but safety mode prevents me from doing that. You are using safe update mode, and you tried to update a table without a where clause that uses a key column, right? So, oops, sorry. Let's go ahead and remember, there's no undo. If you shut off safety mode, it's on you, right? Delete from publisher where publisher ID is equal to 15. Now it's only going to delete that one record, and we can see now that that record is completely gone. Right? Roblox is now gone. Right? I started with those three: inserting records, updating records, and deleting records. Deleting records, because it's the easiest, right? There is no variation there. You delete it, you insert it. I mean, you could. One other thing I might have shown you, though, is a convenience thing here. Before I put this over into the notes, neato, right? You can insert multiple records in one query. Right? So, for example, insert into, maybe now I do want Roblox. Insert into, yeah, let's go ahead and create Roblox there. Except now they're no longer that same publisher anymore, are they? They are 16 now, right? So let's go ahead and insert into game. This is why we use the keyword values, right? Values, because I can insert multiple values here. And the way that I can do that, white space doesn't generally matter. Oops. There we go. And there's a second record, and there's a semicolon at the end. What I want name and publisher ID. All right, there we go. And so I'll go Roblox, and I'll say that their publisher ID. What was it? What did I say it was? 16, right? And I don't know, Roblox 2, right? There we go. And I can insert both of those records. Ah, darn it! What was it? Find multiple. I don't have it in my notes. I forget. I'm screwing this up somehow. Values. Oh wait, operation container. Nope. One column. Roblox 2. Darn it. What was it? We can figure this out in 10 minutes here. It's definitely not that. Nope. No, I mean, it's being highlighted here because that's a keyword, but in the context, it doesn't care about that. Maybe I don't want these. I'm pretty sure I wanted those, though. Let's go with this, and then this. And there we go. All right, so I had some extraneous parentheses at the beginning and the end there. Let's come up and verify that those actually worked. There we go. And yep, we've got Roblox and Roblox 2 now, and they were both published by the same publisher, 16, right? Okay, so you can insert multiple records in there. All you need to do is this syntax here, right? And I'm going to put all that in the notes. And why did and to reiterate, why did I save R for last here? Because that's going to be the most powerful thing. That there's going to be many, many variations of retrieve, right? And we're just going to get started today. Retrieve, that is select, right? Select records, okay? So retrieving, you use the select keyword, word, but it has many modifiers. So I'm going to go ahead and get rid of all of this since I already put it in the notes. There we go. And if you just want to do, a basic select, so here's a basic select, right? Select. There we go. Select star. Star is a wild card. It's going to select all of the columns from game, like we were doing before, right? Star is a wild card that selects all of the columns. I don't care about all the columns, right? If I only cared about one or two columns, what you could do is you could winnow that down. Select name from game, right? I only want the name column, and that will only give me the name, right? Because I don't care about the primary keys. I don't care about the publisher's foreign key. I just want a list of games, right? And by the way, once you do this, if you're using this as an IDE, you can treat it kind of like Excel. You can click it, and it will sort it ascending, descending, and then go back to the original ordering that came out of the, I think came out of the database there. Right? Otherwise, you can always run it again. Okay. And another thing that you can do with your IDE here is should be able to do it. I guess not. Maybe not. All right. You should be able to add things for it to it. Is this the button to do it? No. Resets. Select everything from the game. If I do it that way. Yeah, if I do it that way, if I select star, you see these nulls at the bottom? If you wanted to add a new record here and you didn't want to type out the SQL to do it, you could do it. So let's say 26 and row blocks 3, and they're going to be 16 there, right? Now that doesn't change your database. What you have to do is you have to, execute this, edit, not edit current row, save, probably it, export, no, that's to an external file, import, what is commit? Resets, refresh data with the original query, that's not what I want, that'll overwrite it. I think if I just hit, like close it, it'll say, yeah, then I can say apply. There we go. And that'll tell me the SQL that it'll actually run. It's going to be a little bit more complicated than what I've been doing, but it's the same basic thing. Apply that, close it, it was successful, and we can select everything from the game again and see that now there are 3 row blocks. All right? I'll just keep going with row blocks 4, 5, 6. Right? All right. If you wanted to select multiple things, select, the game ID and the name from game. All you have to do is provide a common delimited list of the things that you want. And now it's game ID name. Remember that that was also the order up here in the game table. The game ID came first and then the name. If you don't care about that, you can always switch them, right? Because columns are unordered basically. So if I said, nope, I don't want to save it. I want the name and then the game ID, right? From game. And it'll switch them around. But that doesn't matter because the order of rows, the order of columns doesn't really matter in SQL. Okay? All right, there are a couple of other modifiers that we can do really quick here. You can limit the number of records. So select everything from game, limit 5. And do you get a choice of which 5 are coming out? No, it's just going to say, well, whichever first 5 I give you, there you go, there they are. All right? Okay? All right. Any questions so far? All right. So now you're exposed to basic CRUD, and you'll be able to at least pull stuff out of the database or whatever, right? And we'll pick it up there on Monday, because remember, there's no class on Wednesday and Friday as announced a couple on Canvas and on Campus Wire. I'll be out of town. We will have lab. Everybody else's help hours will be the same except for mine. All right.